Imagine a future battlefield where the sky is no longer dominated by traditional fighter jets, where speed alone is not enough, and where stealth has evolved far beyond anything seen before. Deep within a highly classified aerospace development program, engineers, military strategists, artificial intelligence specialists, and next-generation propulsion experts came together with one goal in mind: to create an aircraft that could redefine air superiority for decades to come. The result of that vision was the XF-305 Thunder Ghost, a revolutionary sixth-generation stealth fighter designed to operate in environments where conventional aircraft simply could not survive. The story of the Thunder Ghost begins during a period of rapidly changing global military technology. Nations around the world were investing heavily in advanced air defense networks, hypersonic weapons, electronic warfare systems, and autonomous combat drones. Military planners realized that future conflicts would look very different from those of the past. Traditional stealth technology was becoming easier to detect, communication networks were increasingly vulnerable to cyber attacks, and human pilots faced overwhelming amounts of information during high-intensity operations. A new approach was needed. The XF-305 Thunder Ghost was conceived as more than just another fighter jet. It was designed as a complete combat ecosystem. Every component, every sensor, every line of software was engineered to work together seamlessly. The aircraft would not simply fly through contested airspace, it would dominate it. Unlike earlier fighters that relied primarily on speed or maneuverability, the Thunder Ghost combined stealth, artificial intelligence, electronic warfare, and advanced networking into a single platform capable of adapting to any threat environment. At first glance, the aircraft looked unlike anything that had flown before. Its sleek, angular design blended advanced stealth shaping with futuristic aerodynamic principles. The airframe appeared almost organic, with smooth transitions between surfaces and carefully engineered contours that minimized radar reflections from every angle. Special radar-absorbing materials covered the aircraft's exterior, reducing its radar signature to levels previously thought impossible. To enemy sensors, the Thunder Ghost would appear little more than background noise. Powering this remarkable aircraft was a next-generation adaptive cycle engine system capable of adjusting performance characteristics during flight. In fuel-efficient mode, the engines provided extraordinary range, allowing the aircraft to conduct missions across vast distances without refueling. When maximum performance was required, the engines transformed into high-thrust powerplants capable of pushing the fighter to incredible speeds. Military analysts estimated that the Thunder Ghost could exceed Mach 5 during short-duration hypersonic sprints, giving it the ability to reach critical areas faster than any conventional fighter. Speed alone, however, was only one piece of the puzzle. The true strength of the Thunder Ghost lay in its intelligence. At the heart of the aircraft was an advanced artificial intelligence system known as Ghost Core. Unlike traditional flight computers, Ghost Core continuously analyzed millions of pieces of information every second. It monitored threats, evaluated tactical options, managed sensor inputs, coordinated drone operations, and even assisted the pilot in making combat decisions. The pilot was no longer merely flying the aircraft. Instead, the pilot served as a mission commander, overseeing a vast network of capabilities managed by the AI. Through advanced augmented reality displays integrated directly into the pilot's helmet, information appeared instantly and intuitively. Threats were highlighted automatically. Targets were prioritized in real time. Complex tactical data was transformed into clear, actionable insights. This dramatically reduced pilot workload and allowed faster decision-making during high-stress combat situations. One of the most revolutionary aspects of the XF-305 program was its integration with autonomous drone wingmen. These unmanned aircraft operated alongside the Thunder Ghost as loyal companions, extending its reach and effectiveness across the battlefield. Some drones carried additional weapons, others focused on reconnaissance, electronic warfare, or decoy operations. The Thunder Ghost could control multiple drones simultaneously, coordinating attacks with a level of precision that would have been impossible for human operators alone. Imagine a combat mission deep inside heavily defended enemy territory. The Thunder Ghost approaches undetected while several autonomous drones spread out ahead. One drone jams enemy radar systems. Another gathers intelligence from ground targets. A third acts as a decoy, drawing attention away from the main force. Meanwhile, the Thunder Ghost remains hidden, collecting information and preparing for a decisive strike. By the time enemy forces realize they are under attack, the mission is already complete. Electronic warfare capabilities represented another major leap forward. Modern battlefields rely heavily on information networks, sensors, and communication systems. The Thunder Ghost was designed to dominate this digital environment. Its advanced electronic warfare suite could detect enemy transmissions across multiple frequencies, disrupt communication networks, confuse radar systems, and launch sophisticated cyber attacks against hostile infrastructure. In some scenarios, the aircraft could effectively blind entire air defense networks without firing a single missile. Enemy radar screens might display false targets, communication channels could become unreliable, and command systems might receive misleading information. This digital battlefield dominance gave friendly forces a significant advantage long before traditional combat even began. The weapons carried by the Thunder Ghost reflected its advanced design philosophy. Internal weapon bays preserved stealth characteristics while providing space for a diverse arsenal of missiles, precision-guided munitions, and future weapons systems. Long-range air-to-air missiles allowed the aircraft to engage enemy fighters far beyond visual range. Advanced air-to-ground weapons enabled precise strikes against high-value targets with minimal collateral damage. Perhaps most impressive was the integration of directed energy weapons. Experimental combat lasers mounted within the aircraft offered new defensive and offensive capabilities. Incoming missiles could be destroyed within seconds using focused energy beams. Enemy drones could be disabled without expending traditional ammunition. As technology continued to mature, these systems promised to transform aerial warfare in unprecedented ways. Survivability was another key priority during development. Military planners understood that future battlefields would be saturated with sophisticated threats. To address this challenge, the Thunder Ghost incorporated multiple layers of defense. Stealth technology reduced detection probability. Electronic warfare systems disrupted enemy targeting. Artificial intelligence identified threats instantly. Directed energy defenses intercepted incoming weapons. High-speed maneuverability provided an additional layer of protection when all else failed. The cockpit itself represented a dramatic departure from traditional fighter aircraft. Large touch-sensitive displays were replaced by immersive augmented reality systems. The pilot's helmet projected mission information directly onto the visor, creating a seamless connection between the pilot and the aircraft. Looking at a target automatically displayed relevant intelligence. Turning toward a threat revealed defensive options instantly. The result was an intuitive combat experience unlike anything available in previous generations of fighters. Training for Thunder Ghost pilots also evolved significantly. Advanced virtual reality simulators replicated real-world combat environments with astonishing accuracy. Pilots could train against sophisticated AI-controlled adversaries, practice complex mission scenarios, and develop skills without ever leaving the ground. This accelerated training process while reducing operational costs and risks. Beyond combat operations, the aircraft's reconnaissance capabilities were equally impressive. Advanced sensor arrays combined radar, infrared imaging, electronic surveillance, and satellite connectivity into a unified intelligence platform. Information gathered during missions could be shared instantly with commanders, naval forces, ground units, and allied aircraft. The Thunder Ghost functioned as both a fighter and an airborne intelligence hub. Strategically, the introduction of the XF-305 Thunder Ghost had far-reaching implications. Military analysts viewed it as a force multiplier capable of reshaping global airpower dynamics. A relatively small number of Thunder Ghost aircraft could achieve effects previously requiring much larger formations of conventional fighters. Their ability to operate independently, coordinate drone swarms, and dominate contested environments offered unprecedented flexibility to military planners. The aircraft also reflected broader trends in military technology. Artificial intelligence, autonomous systems, cyber warfare, and networked operations were becoming increasingly important components of modern conflict. The Thunder Ghost represented the convergence of these technologies into a single platform capable of adapting continuously to changing battlefield conditions. As testing progressed, engineers pushed the aircraft to its limits. Flight evaluations examined every aspect of performance, from stealth effectiveness to engine reliability. AI systems were subjected to countless scenarios designed to identify weaknesses and improve decision-making algorithms. Drone integration underwent extensive validation to ensure seamless coordination during complex missions. Each successful test brought the aircraft closer to operational reality. Observers who witnessed demonstration flights described an aircraft that seemed almost unreal. Rapid accelerations, near-silent approaches, and precise maneuvering showcased capabilities far beyond existing fighters. During some exercises, the Thunder Ghost reportedly completed objectives without ever being detected by opposing forces. Such performances fueled speculation about the future of aerial warfare and the role advanced technologies would play in shaping military strategy. Despite its impressive capabilities, developers emphasized that technology alone could not guarantee success. Human judgment remained a critical element of combat operations. The purpose of artificial intelligence was not to replace pilots but to enhance their effectiveness. By reducing cognitive workload and providing superior situational awareness, AI allowed pilots to focus on strategy, leadership, and mission objectives. Looking ahead, many experts believe the Thunder Ghost would serve as a foundation for future innovations. Modular architecture allowed upgrades to sensors, weapons, software, and propulsion systems as new technologies emerged. This adaptability ensured that the aircraft could remain effective for decades despite rapidly evolving threats. The aircraft's influence extended beyond military applications. Research conducted during its development contributed to advances in materials science, artificial intelligence, aerospace engineering, and energy systems. Some of these innovations eventually found applications in civilian industries, demonstrating how cutting-edge defense programs often drive broader technological progress. As geopolitical competition intensified, the Thunder Ghost became a symbol of technological superiority and strategic deterrence. Potential adversaries understood that confronting such an aircraft would require entirely new approaches to defense. Existing systems designed to counter previous generations of fighters might prove ineffective against a platform combining stealth, AI, hypersonic performance, and autonomous support systems. The legend of the XF-305 Thunder Ghost continued to grow with every successful test and operational exercise. Aviation enthusiasts admired its futuristic appearance. Military professionals studied its capabilities closely. Defense analysts debated its impact on future conflicts. Regardless of perspective, few could deny that the aircraft represented a remarkable vision of what air combat might become. In the end, the Thunder Ghost was more than a machine. It embodied decades of technological advancement, strategic thinking, and human innovation. It demonstrated how emerging technology